Hello everyone, this is the video lecture for College Algebra, Math 1414, Section 4.1. We're talking about exponentials. Exponentials, I put EXPs. Exponentials, something kind of like exponential growth. That's exponential growth, or we could have exponential decay. These are real-world applications, growth. I know a lot of people say population growth is not really that way, but, well, it's close enough. Population growth, I guess. Bacterial growth, that's another one. Decay could be the temperature of your hot coffee going down to an ambient temperature of the room. It could be, well, radioactive decay, I guess, or even decay of drugs in the bloodstream. So lots of actual real applications in this, not just this section, but this entire chapter. Is not just exponentials for the whole chapter, but that's going to be the focus for today. Let's just get started on some problems here. I got 4.1.3, and they say find 8 to the power of square root 7 is approximately, and of course they are wanting you to use a calculator. So grab a scientific calculator, and you get 245.1046. Now here's the thing. I think that these problems, this one and the next one, are just wanting you to say, hey, do you have a calculator that will do this stuff? So, like, you know, your phone might not do it. I don't know. Maybe if you turn it sideways, it'll do it. But that's not the point here. We're looking for, like, you know, a good scientific calculator. So find one, get one. We don't have to have something fancy. This is some basic stuff here. There's probably an app for that. And of course, I also recommend Desmos Scientific Calculator is always good. I don't know if I've ever mentioned Desmos. Desmos.com. They have the scientific calculator. They also have their really cool graphing calculator. But I'm focusing on the scientific there. I'm not going to show you. It's pretty easy to use. Okay, so now I got e to the negative 0.73. Well, e is a special number. E is approximately 2.71828, da-da-da-da-da. It'll keep going on and on. Kind of like pi goes on forever, E will go on forever. And I put this into my calculator, and I got 0.4819089. Round to whatever decimal place they're looking for. So, there you go. Do you have a calculator that does this? Great. Now we're going to keep moving. So 4... that's an ugly 4. 4, 1, 11. I got f of x is equal to 2 to the x. And they have a table for me. X and y. Negative 2, negative 1, 0, 1, 2. And so I've got to find all these values here. So that 2 is called your base. The x is called your exponent. Close enough. And so I'm going to plug it in. I'm going to plug in negative 2, plug in negative 1, see what happens. So 2 to the negative 2, what do we get? 2 to the negative 1, what do we get? Let's start with 2 to the 0. What's 2 to the 0? Anything to the 0 power is a 1. So that was easy. What about 2 to the 1? 2. What's 2 squared? 4. What you're doing here, though, is you're going to go inverse. So 1 is kind of like your pivot. And this guy here, notice he got 1 and negative 1. Negative means it's going to be a fraction. It's not just 2, it's 1/2. And this guy here, you're going to still square it, but because it's now a fraction, it's not 4, it's 1/4. So that's how that works. At least that's how I see it. And then, of course, they want you to pick one of the graphs. It grows. Actually, this 2 base is saying that it's doubling each iteration. And one of the key points you can look for is 1, 2, which is, well, actually right there. X was 1, your answer was 2, 1, 2. So there you go. Okay. Let's keep going. I got a lot of stuff I could talk about, but I'm just going to get to it. 4.1.19. This problem is a matching problem. It's not multiple choice anymore. It's like a matching. And there are a ton of options. Now I'm putting F for all of them. On the My Math Lab, they put all kind of different letters. I'm just super lazy about doing something like that. Very improper to use the same letter again and again. No way a true mathematician would do that. Sorry, that was a joke. Moving on. So we got all these numbers and letters and stuff, and we need to match them up. Actually, I should have given myself some room for these guys. I'll just graph above and below. Okay, so this guy here, we got our... Well, let's start over here. This is my original. Notice that everything around here, what do you see? What's a predominant thing is it's 9 to the x. And so this is my basic one. 9 to the x looks like this. Its growth, it's 9 times as big each iteration, so it's going up. Well, notice here we're saying it's 9 to the x, but then I'm shifting it down by 1. So it looks something kind of like this. It's just shifted down by 1. Same kind of graph. This guy here, he's flipped upside down, so he's going down instead of up. This guy here is flipped upside down and flipped to the side. So our original looked like this, then I'm going to flip it to the side, and then I'm going to flip it down, so it looks kind of like that. This guy's only flipped to the side, so he'll be decay, actually. And then finally, this is a shift to the right by 1. I'd say this is probably the hardest one to tell the difference between this one and this one. This one should go through at 1, like a 1 height right here. That's at 1. This will have a 1 somewhere over here because it's been shifted over a little bit. It might actually be at 1, 1. So look out for that. Okay, that's a hard one to kind of tell because you have to zoom in and check and all that kind of stuff. Okay, 4,153. I got A is equal to P times 1 plus R over N to the NT. They give me this cool formula. And then we have A is equal to P times E to the RT. The PERT formula. Okay, maybe you've not seen the PERT formula. That's whatever. So this is, both of these are for compound interest. Compound interest. Okay. And it kind of depends on what kind of interest we're talking about. So PERT formula is for continuously. It'll say the word continuously. And anything else is going to be this guy. We could have annually, semi-annually, quarterly, monthly, daily, weekly. There's all kind of things, of course, that'll go there. So this particular problem says we got a principal of $25,000. We have t equals 7 years that I'm going to put it in a bank, some kind of savings account or something. My rate is 4% interest rate, which translates to being 0.04, which at this time of the recording, 4% is super awesome. It might change, I don't know, but as far as I know, there's no way for you to find 1% for you to gain money. And now, of course, if you're having a credit card, 4% might be a good deal for you to have to pay them back. There is a difference, of course, but we do what we can. So they're wanting part A is, hey, let's put this in this really cool, awesome bank account, and I want to compound it semi-annually. That is, n equals 2 times per year. Well, I'm just going to use this top formula here. So I've got my 25,000 times 1 plus my rate, 0.04, all over 2, and to the power of 2 times 7. Now, you definitely need to put this in a calculator. The thing is that older calculators, newer calculators, lots of calculators going on. If you have an older calculator, it will end up looking like, I'm going to go ahead and put a 14 here. 14. What you could also do on the older calculators is you could have 2 times the 7 like that. But notice that I'm keeping it in parentheses. Very important. I had mentioned Desmos, and I typed this into Desmos, and it really wants this parentheses action here. It doesn't look like this. It looks like this, like the newer calculators. But as I'm typing it, if I do 2 and then a 7, it'll try to drop that 7 down. And so to prevent that, you need a set of parentheses like this. Or you could just make it a 14. So I honestly suggest the 14. It makes it super easy. And so then that way you can avoid all this confusion. Let's put it into calculator. New, old, Desmos, not, whatever. And I got 32,986.97, and that's again dollars. So think about it. We had $25,000 and we put it in this really awesome big account for 7 years, and this is what I got out of it. So I made what, $8,000? That's pretty good. I made $8,000 from $25,000 over 7 years. So cool. That's a good idea. Okay. Of course, that you had to have the $25,000 to start with, and you had to not touch it for the whole time. Quarterly. Quarterly. How many quarters? 4 quarters a year. 4 quarters in $1. I'm going to just rerun the same thing, but instead of a 2, I put a 4 now. And 4 times 7 up there. 4 times 7 is 28, so you could just simply replace that with a 28, put it in the calculator, get an answer, and I get, I'm looking at my notes here, 33,032.27. Again, dollars. Notice that I got more. So the thing is this quarterly, semi-annually stuff, I'm looking at my account ever so often. Well, the bank is, and they're giving me money. So think about it like this for a second. They're going to look at your account 2 times a year, and that's cool. So they give you interest back 2 times a year. That's cool. But what if they were to do it quarterly? Ooh, now there's doubling the amount of times they're looking at it. Doubling the amount of times they give you interest. So yeah, you do get more. I mean, look, you obviously get more, but it's not a significant amount. So just a thought there. If you keep going onto the annually, the monthly, the daily, and all that stuff, you'll creep up a little bit more and more. But the most should be continuously, and that's what they're going to ask for now. Continuously means basically n equals infinity. They're looking at your account every minute of the day, and they're trying to give you back interest all of the time. Now, when they give you back interest every minute of the day, it's not going to be 1/100th of a penny. It'll be very, very tiny. And so I try to put an infinity in here, and that's not going to work. Right? Didn't I just replace these with infinity? No. There's a special formula for it. So if you go back up, right here, the PERT formula, all I'm going to do is just rewrite it as hold on, that was an E. 25,000 E to the 0.04 times the 7. So I just put it in like this instead. That's a times sign there, of course, and et cetera, et cetera. Use parentheses, et cetera, et cetera. And I got 33,078.25. That is the very most money that you can get from that account at that rate for that amount of time. So you can see that we got an extra, well, actually from the very beginning, the semi-annually, we probably got almost an extra $100, right? So that's not too bad, but I mean, $100 over the course of 7 years is not nearly as much as you think. Moving on. 4171. So I've got f of x. Oh, this is a word problem, by the way. F of x is equal to x plus 25. And then I have a g of x, which is equal to 32.8 e to the 0.0217x. And they're saying that x is years after 1980. Okay. They also have a bar graph associated on the side here. Kind of looks like this here. And here they are talking about 2010 in particular, and I have a 62 up there. Okay. So part A, they say use the linear model, the linear line model for 2010. Sorry for my sloppy handwriting. So 2010. So I'm going from 1980 to 2010. How much X do we got? We got 30 years. And so I'm going to use the linear model. Linear means, a line, mx plus b. That's a 1 right there, etc. So I'm going to plug that in. 30 plus 25 is 55. Cool. Part B says now use the exponential model same thing. So I'm going to now plug in the 30 into the 32.8 e to the 0.0217 times 30 now. I use the calculator and got a 62.8926. That's my answer for part B. And they say part C, which is closer to the bar chart. If you look here, we got 62. So 62 compared to 55 or 62 compared to 62.89. Yeah, we got our winner. So we're going to say the exponential is better. Okay, this is the last problem, actually. It's a fairly short section. So here we go. F of x is equal to 70 e to the negative 0.5x and then plus 30. And they're talking about x is weeks after learning something. And this percentage is the retention of learning. So what percentage of folks would retain this knowledge after some X weeks after learning it? Okay. It's kind of interesting because we're doing math, you're learning math, and I wonder if this formula applies to you or even to me. So let's try some stuff out. So part A says how much have retained that learning, how much percentage of people retain that learning the moment it was learned. How much time has passed? How many weeks have passed? 0 weeks. So I plug in a 0, and I just figure, plug in a 0. The whole thing's going to cancel or something. Nope. When you go and put it in the calculator, I got 100. Yes, that is 100% of people remember what they were taught the moment it was learned. You see, that's kind of funny. Like, hey, what section are you learning? I'm learning about exponentials. There you go. 100% of people can say you're learning exponentials. So, cool. All right. 1 week later, how many people still remember what they were taught? So that's x equals 1. I'm going to plug it into this formula. And this one actually gives you like a decimal return, not just a 100%. See how they got that 100? See 70 and 30? You see that? It's pretty interesting. We'll use that here in a bit. Anyways, I plugged that whole thing in, and I got 72.45714%. So 72% of folks remember what they were taught 1 week later. Now, you would say that's still a majority, I guess. A fair amount of people have already forgotten just a week later. I guess that even includes me sometimes. 12 weeks later, x is equal to 12. Plug it in. Calculator. Same as always. I got 30.1735%. Only 30% of people remember what they were taught 12 weeks ago. That's 3 months. You can almost think of it like a semester. Will you know this math a semester later? I do hope so. So, part D, it says, what's going on after 1 full year? And what we have, x is actually going to be 52. But when you plug that in, it won't even give you a decimal, I don't think. It'll just give you 30. The reason being is because this exponential section right here, it basically goes to 0, but it retains the 70% that's always remaining here. Okay, so 30% of folks 1 year later will remember exactly what we were taught. Hopefully that's you as well. Okay. So I guess this is good that you take math consecutively and quickly and don't have breaks in between. Just a thought. All right. Thank you very much. Have a great day.